we shall learn Norrish type 1 reaction. Norrish type 1 reaction is also called as alpha cleavage reaction. This reaction we can observe in saturated acyclic ketones and saturated cyclic ketones. In this reaction, there will be a cleavage of bond alpha to carbonyl group. Norrish type 1 cleavage originates from the carbonyl N pi star state. So we should learn what is this reaction using an example. First we will take acetone. This is in ground state. When you shine light on this, it will undergo excitation. So that excited molecule you can show like this. You can put inside a bracket, and this is S1 state. S1 state, which is N pi star state. N pi star state. So generally carbonyl compounds undergo N pi star transition. So this is singlet state. Now when this undergo intersystem crossing, it leads to triplet state. So the system moves to triplet state. So this one is the triplet state of N pi star. So this is also N pi star. And in the triplet state, the reaction takes place. This bond is the alpha bond, and this bond is also alpha bond. So any one of this would break, because in this case both sides it's identical, so I can break any one of this. So let's say I break here, and this results in formation of CH3 C double bond O dot, a radical, plus CH3 another radical, methyl radical, and CH3CO dot are formed. And till here is referred as primary process. Now all the photochemistry takes place here in the primary process. All the photochemistry takes place. Now let's move on. What happens to the formed radicals? CH3CO dot, this is the radical that's formed, and this can undergo decarbonylation to give CH3 radical. So this bond breaks in a homolytic manner. This portion becomes carbon monoxide, and this portion becomes methyl radical. Now two methyl radicals can undergo combination, radical recombination to generate a stable compound. In this case it is ethane, and these two processes we refer as secondary process. So Norrish type 1 cleavage of acetone, the main product is ethane. Now let's move on to another example of Norrish type 1 using cyclic ketones. I will take another example. the same Norrish type 1 process. I will take the example of a cyclic ketone. This is cyclohexanone. When you shine light on this one, it moves to singlet state, right? So I'll just write S1. Here also it is N to pi star transition. Then the system moves to intersystem crossing, undergoes intersystem crossing to give triplet state. So I can write here the cyclohexanone in triplet state. This is T1 N to pi star. All right. Now in the triplet state, the photolysis takes place. Photolysis takes place. So in this case also, any one of this bond can break. You can break either this bond or this bond because both are identical. So I break this one. So what you get is a radical, and here another radical. So till here, till this one, it is referred as primary process. So all the photochemistry happens here. Now let's concentrate on the secondary process. In secondary process, what happens? So two things happens in secondary process. So I split the page into two. So you have a diradical. This is a diradical. This can undergo decarbonylation. So carbon monoxide will be removed. So this bond breaks. This bond breaks. Decarbonylation. So you will get a diradical like this plus carbon monoxide. This is a 1,4 diradical. You can see here 1, 2, 3, 4, 5. Sorry, this is a 1,5 diradical. Generally, 1,5 diradicals will undergo cyclization. So what happens to this is cyclization. When it undergo cyclization, you get cyclopentane. So this is cyclopentane. Cyclopentane. Now another thing can happen to this diradical, that is intramolecular hydrogen abstraction. Hydrogen abstraction is going to take place in an intramolecular fashion. Let's see what is it. So you have a diradical, and of course we have a hydrogen here. This radical carbon would abstract this hydrogen as H dot. It means hydrogen atom. So what I do, I break this bond in a homolytic manner, and of course this radical can come here. So a double bond will be formed between these two, and this hydrogen will be abstracted by this carbon. So what do you get? You get this hydrogen will be attached here, and here double bond would be formed. Just a minute, I'll write it better. This hydrogen is attached here, and you get a double bond here. Okay, so two products are possible. So with the cyclohexanone you get this diradical. Then this diradical can undergo two type of reaction. One, it can undergo decarbonylation and then radical recombination, or otherwise we can call here cyclization to give cyclopentane. Otherwise this radical can undergo hydrogen abstraction in an intramolecular fashion to give this compound. Thank you.